we have a real treat for you because we get to look at the most fun thing in the world, databases. Yeah, we're going to start off. Mike's going to talk about MySQL, which is probably what you're most familiar with. And then after that, I will come up and talk about not MySQL, which is what you should use. So, without any further ado, the man you know and love, Mike!
Hey, how you guys doing tonight? Good? Yeah! Nice. How are the final projects going? Who started? Nice. Who's got something on GitHub? There you go. You're not started until you have it on GitHub, okay?
I've actually got it posted live already in production.
Really? That's perfect.
Yeah.
So, have you guys seen LaunchCode TV? Anybody go to us.launchcode.us? Yeah? Is it okay? You guys like it?
Yes.
Alright, we're just getting started. This past week we uploaded about 12 new videos for you guys to view. Guys, consider these your shorts that you guys get every week from CS50. We're going to do our best to upload the best data we can for you guys so you can figure out tips and tricks to get things done. So, we'll have some more videos coming out later on this week, but definitely go check it out. It's tv.launchcode.us. So, let's see.
Hey Mike.
Yeah.
I tried that on a search in Google. Didn't
Yeah.
find anything. We had to go to the Reddit post and bring it up there, and then we bookmark it.
Yeah, Google hasn't figured out how awesome it is yet, but if you guys all tweet it or blog it, then Google index it really fast. So that's how those things happen. Do a little SEO magic for me. Hashtag awesome. All right, so you guys know it's a bad sign whenever the presenter is asking what the MySQL database password is right before he gets started. So Kim was actually kind enough to lend her laptop to me tonight because apparently it takes 6 engineers to write some simple database queries. So along that point, let me just show you guys something really important to every single database out there. The reason why it takes 6 engineers to write a simple database, and that is a MySQL dump file. Anybody heard of one? Use one? Nice. Okay. If you guys are going to work on a team with a database, this is absolutely essential because what you do is you say MySQL dump out the database, and it's going to create all of the SQL to generate that database on somebody else's machine. Because you know you can't put these databases in GitHub. You have to have some type of textual form that you can represent these databases in. So, I mean, big props, Kim, for having a database file that she saved in it. What? Yeah. Like, that's perfect. I mean, there's no way we could have generated that much data here in just a couple of minutes. So, that is huge. Give Kim a round of applause for being on the ball. All right, so essentially what you can do with this MySQL database file is you can say, just real simple, log into MySQL from the command line, say -u jharvard-p, which means you're going to ask for the password later, and just do this little arrow sign with the SQL file that you'd like to inject. And that's going to inject the entire SQL file, run it, and make it into your own database. So let me show you guys what it looks like.
Hey Mike.
Yeah.
Can you make that any bigger?
Oh,
Yeah.
I can read it on the video.
You can?
Yep.
All right, we're going to make this happen. All right, excellent. So asking for my password, you guys know how this works. You're just typing password. Has anybody used MySQL from the command line? You guys all using PHP 9? Yes, yes. It's good. It's good. It's good. All right. So first thing is you have to tell it what database you want to use. You say I want to use pset. Actually, we can type in command show databases. Here are all of our databases. Let's say use pset 7. Okay, great. Now if we want to see what tables exist, we just type show tables. Nice, right? So what if we want to say, I want to see everything in history, but I don't want to load the entire table. I just kind of want to see what it looks like a little bit, what's in the data type. So we can use this limit command. We can say like limit 3. So it's going to pull in 3 records, and it's going to give us the column headers, and it'll give us some real nice information. So that's an introduction to how to get started with MySQL on the command line. A little background on why you should use MySQL. MySQL saves you guys from writing loops, guys. I mean, this thing we call a database, remember in the last talk, we said a database could be anything. It could be, we could make a CSV file and call it MyDB, and that would be considered a database by modern terms. This database just has tons of functionality encoded into the language of SQL that prevent you from writing loops, prevent you from writing loops on filtering data, prevent you from writing loops on combining data, and prevent you from writing loops on linking data. So those are the 3 things I'm going to talk to you guys about today. And maybe if we're lucky, we can get some database design. But Keegan. What? I need you to cut me off at like 11 minutes, okay? All right, so basic command to query the database. Anybody? Yes. So we can use select. The star means pull in every single column. If we don't want every single column, we can just pull in transaction and date, time, from, history. Boom, that's a valid command. So you guys know that. How about how to filter data? What do we say to filter data? Yes, nice. All right, so let's actually put a where statement on here. We can say where, actually I need to see what the table looks like again. There we go. Where transaction equals 5. All right, that's pretty easy. You guys know how to do that. How do you group together data? How would I take a sum of all of the shares that have been bought so far? Okay, this is something you definitely don't want to do in your code. Do as much stuff of this as you can in the database. Because you have to write a lot of code to get done, and that's not going to be very much fun. So the database probably has a bunch of nice built-in functions that you can use. So you can say select sum of symbol, actually sum of shares. From history. Okay, that's how you total the sum of shares. And now we can even put where statements on here. So we can be like, hey, where transaction. Or yeah, how many do we sell? Yeah, guys, we can ask this database any question we want, and it will tell us the answer. And so do the stuff in the database. Don't do it in your code. If you're tempted to do something like this in your code, stop and look up your database documentation immediately. How about if we want to see, well, let's take a look at the table again, what it looks like, just to refresh my memory. Okay, what if we want to see what if we want to group, what if we want to see how many shares were bought of each symbol? How would we do that? It's kind of a crazy query, right? Because we have to loop through, find all the symbols that are the same, find which ones were bought, and then add them all together.
Use group by.
Yeah, use group by, right? So watch this, guys. So we can say, all right, we're going to say sum, just like that before. But now we can say group by, and group by equals symbol. Yes. How about that? So it's going to return us every symbol, how many were bought of each symbol, how many were sold of each symbol, and we know that because we're saying group by symbol. Enter. Shoot. The where comes last. The where comes last. Nope, actually I was wrong again. I shouldn't put quotes around this. Oh my gosh, he can save me.
I'll get rid of the equal sign.
Oh my god, good call. Nice. Thank you guys. Who was that? Yes. Thank you, man. All right, so that's how we ask the database how many were sold of each stock. Now we can really easily change this to how many bought each stock. You guys can have access to all of this information right away. It's extremely powerful. This is why Larry Ellison owns 1 out of the 8 islands in Hawaii, is because he's able to allow people to capture data and use it like this. And I mean, he's not the only one. There are plenty of databases out there that you guys can use. There's Oracle and MySQL. MySQL is got bought with the Java purchase of Sun Microsystems a couple years ago. So you guys will notice that you're running MariaDB. That's actually the open source version of MySQL, which is good. And then there's Postgres as well, which is awesome. But let's see, I told you guys I was going to show you how to query data, filter data, sum data, and then link data. Okay. Who's done a join in class so far? Yes? Nice. All right, that's awesome. At least a couple of people have. Who was here for the last talk about NoSQL? Yes. All right, remember how we talked about databases? The way they work is that we're able to split data up into separate lists. Otherwise, we'd have just a bunch of redundant data. So in this case, we assign an ID to every item in this list. So the way databases work, as we talked about last time, is we're able to divide things up into these 3 separate lists: history, portfolio, and users. And now we can bring them back together with join statements. So if we want to say, we want to join portfolio with users to see what users have what portfolio, we can say select star from portfolio as P, inner join users as U, and now we can say where P ID equals U.ID. So this as statement, we can essentially alias each table because it gets upset if we don't tell which ID we're talking about. So we have to give it a different name. And so let's say this. And now we can actually join these 2 tables together. We can take these 2 separate lists that we saw before, and we can bring them together in one list, one combined list, and combine all their data together. Yeah, so this is all pretty straightforward. It's one list. Things are pretty straightforward with databases as long as you've got a one-to-many relationship, like a parent-child relationship. So think about it like if you've got a city, every city can have multiple baseball teams, but a baseball team cannot have multiple cities, right? So that's an easy relationship to map because, you've got your city, and then in your baseball team table, you've got the city ID that represents where they live. But let's take another example where if we're looking at like the CS50, let's pull up the CS50 lookup real quick. Say CS50. Oh, it's not necessary. But what if we're talking about students to problem sets? Now, there can be many students to one problem set, but a student can also be on many problem sets, right? That's not such an easy relationship. In that case, you guys would want to use a join table. And I don't have an example up here right now, but just remember the word join table. If you think you got something funky going on, something tricky where they're referencing each other, do a join table. And so you would have a table that maps what problem set. Each user is on, I think. Is that time? Thank God. All right, I'm done. Chris Keegan.
All right, so now that you've had that torture done with, don't worry, we actually are done with that for now. I can talk about NoSQL and Mongo, which are really databases for the way we want to store data. And I mean, let's face it, I want to be lazy, don't you? So SQL is structured query language. It's meant to be, simple, language agnostic, relational storage of information. You can use MySQL, Postgres, whatever from any language because SQL is its own language. It's also very rigid. If you mess up at all, if you don't have the complete idea of exactly what you're doing, it's not going to go well for you. So what is NoSQL? NoSQL is not only SQL. It's not SQL. It's not only SQL. It does more and sometimes less. It is very complex because there are about 3 different things that people consider NoSQL. And it's very popular. And in some cases it can be way faster because your entire data set will live in memory. So the first type of NoSQL databases we have are graph databases. That's when you have complex interactions. They're very popular for examining social interactions. So if I want to visualize, 3 people like we have up here on the screen, and their interactions, then a graph database is great for that because you can travel along these different relations in different ways and see how everything is interconnected. So I've just got a couple up there. We got Neo4j, VertexDB, OrientDB, all very popular choices. Then we have key value stores. So everything has a key and a value, and you can only get the value by the key. So instead of having, rows and columns, you have one row that is what you can look up by, and then a column for the data. So, if I've got my user Keegan, I can't search by password or GitHub or anything like that. I have to know that I'm looking for user Keegan. So in that category, we've got Redis, which is really awesome and has some crazy things that you can do with it. Memcache, LevelDB, and then Tokyo or Kyoto Cabinet. And finally, we get on to the awesome one called document databases. They store things similarly to SQL, but they can be more performant, they can be easier to scale, and they're way easier to develop for. So I'm going to talk about Mongo. Other popular choices are like CouchDB, technically Solr and Elasticsearch, which allow you to really easily do some awesome full text searches, right? If you have some big chunk of information, you can search inside of that. Where MySQL, that's almost unthinkable. It's so slow. So for document DBs, instead of columns, you have properties, basically. Instead of rows, you have documents, and instead of a table, you've got a collection. So a document, it has properties. You can look at collections of documents, right? You've got multiple documents. But the really interesting thing is that documents don't need to have the same properties as other documents in the same collection, right? So I could have one document with the property name, and I can have another document with the property GitHub, right? And if I search for the for a document containing where GitHub is equal to this thing, it'll find those, and it'll just ignore the rest of them because it doesn't have that property. So why does this matter? Really fast to develop for. You don't have to predefine your schema. You have to define, this is going to be an int, this is going to be a varchar, this is going to be text, whatever. You don't need to do that. Yeah. We were trying to remember how to do that before the talk, and it did not work out well. You're able to store arrays, and you're even able to put a document inside a document, because, yo dog, I heard you like documents. So, for example, here's a single document, right? We've got an ID, a name, then we've got aliases, right? We've got array of aliases. And then we have favorites, right? Where we have a document that are favorite things. So if we tried to represent that in SQL, we end up with something like this mess, probably. No, let's not do that. Not fun. Let's not do that. So, now the boring part is over. We're actually gonna go ahead and install and use Mongo a little bit. Whoop, that's not. So, first thing you do, you Google install Mongo, and then technically the CS50 appliance you're using, it runs Fedora. Install MongoDB on Red Hat Enterprise to analyze Fedora. How do we do it? We just install MongoDB org for everything. So let's try that. Yum, install MongoDB org. Yes, of course. I need to make this bigger, don't I?
Yes, you do.
Preferences? Maybe? I don't make it bigger. There we go. Wow. 24, even better. Is that for one up, Joe? So we wait on the very slow internet. That's never good. So we go ahead, it downloads all this stuff. You gotta keep track of what's going on, what depends. It needs certain things to install Mongo, so it has to know what it's doing.
What's Yum?
Oh, Yum. Yum is Yellow Dog Update Manager, I think.
Is it kind of like fgit?
It's kind of like fgit if you're familiar with Ubuntu.
Yeah. So it just installs stuff on the command line. You don't have to download it or anything?
No, it just like you say Yum install whatever, and it installs whatever.
Wow, that's really easy. I had no idea.
Yeah.
There's one for Mac called Brew.
Yeah, there's one for Mac called Brew, or there's one other one that people use instead of Homebrew. I forget what it is. I don't know why you'd ever use a Mac though.
How about if you're actually being paid to?
I
Good
would
excuse?
I'd put a VM on there and not use Mac.
Okay, I'll remember that.
Yeah. So we'll let this do its thing, and then hopefully at the end of this, we come out on the other end with Mongo installed, and I can show you how awesome it is. The neatest thing about Mongo is that the Mongo shell is JavaScript. Just period, it's JavaScript. You don't have, if you know JavaScript, you can screw around in the Mongo shell. There's more. What? I don't know. Let's.
Well, I mean, the appliances Fedora is kind of like a locked up kind of old thing.
It's Fedora 19. That's.
It's appliance 19.
Yeah, it's a point.
No, see, Fedora 19. It wouldn't be getting Fedora
Okay,
19
well,
if it
maybe
weren't.
that's where they get the number from, but I just got the impression that it wasn't completely up to date.
I think some of the packages on it aren't up to date and can't be updated
Well,
because
and
of
your
specific
appliance isn't up
things.
to date either, it's 19-0 to 19-2.
Oh, yeah.
It didn't let you do it.
See, read before you actually do. Finish reading because I have to set this up. All right, so we need to create this file. So we're gonna Vim it, and we're gonna copy paste it. We're on a 32-bit system, so we need to use this one, which, as it says, won't let me click.
Do right click.
I am right clicking.
Really?
You have to edit page.
That works.
Good old Vim.
No, see appliance.
Now I need to be ready. Again. Shift Control V. Interesting. Remember that? So now we can do that.
Okay.
So now it'll take a long time to get the rest of it.
And it still didn't let you do it. Oh,
No, it's installing it.
okay.
Resolving dependencies. It's gonna install some stuff. Yes, please, just do it.
So we have to create the environment for it to download?
You have to tell it where to find the stuff to download, basically. That's what you're doing. I wanted to show you guys this, but I did not think it would be so slow. It's slowing down. There we go. So, yeah, Mongo, the Mongo shell is just a JavaScript shell. So theoretically, anything you know in JavaScript, you can run inside of the Mongo shell. So like you could like set timeout something. You don't want to do that, but you could. Yeah.
This is gonna be a really awesome video later.
Right? Yeah. Right, because hopefully later, you know, when somebody looks at the video, it'll be like, all right, guys, let's install Mongo. Now that we've got Mongo installed.
Post.
The SpongeBob transition, several hours later. So let's do what I do in my free time. Let's look at Reddit.
Cats.
Let's go to a good subreddit. Programmer humor. Let's see what's funny. So, yeah, there we go. There's something I can talk to you guys about. Have you guys heard of this Heartbleed thing?
Yeah.
Yeah, so basically what that means is that, like, 2/3 of the internet was potentially at risk for having anything stolen, like everything stolen. So, that's not good.
Change your password.
Yeah, change your passwords, hide your kids, hide your wife. So yeah, that's not so funny, but Rails HTML5.
So basically use HTML5 and anything at version.
Yeah, well, HTML5 has absolutely
What's
nothing
the
to do
issue
with
with
this.
this stuff with Grid?
So the issue is that, like, yeah, and it's not, theoretically it's not your passwords that would be at risk unless they're really, really silly and have their database on the same server as where they're terminating their SSL connections. Yeah, so don't do that when you guys have your own sites. Don't have your database on the same server as your web stuff, because then
What's
it's
where
something.
a lot of people have it.
Go with like some other host where you get, you know, a server that you can use that you don't care where it is, but it's on some other machine. Like,
That doesn't make any sense to me.
like there are lots of hosts like Bluehost, or I don't even know because I run my own stuff, so I don't worry about it. But
You're talking about like different machines, right?
yeah, physically separate machines, so that like if the SSL bit of it is compromised, the session data isn't, because the SSL runs on an SSL terminating box. You got your web server stuff running here, and you have your database here. That's one way. The other way is like if you have to enter credentials into where you use, where you connect to MySQL, if you have to say it's on a different server, then it's on
Probably on a different server.
Yeah.
Okay,
But if it
that's
just
good.
automatically works out of the box, localhost 127.0.0.1,
No.
it's on the same machine, don't, yeah. All
right.
right, so now we have Mongo installed, holy cow. So I think we have to start it. I think service works. And it's service MongoDB start. Why am I still not root?
It's using system D.
Right, but service should work, right? There we go, MongoD, there we go. We're good. Mongo is now running. That green OK means Mongo's running. So if we just type in now, Mongo, we're in Mongo. It warns us, don't use 32-bit, because 32-bit is old and bad. So, now that we're in Mongo, what are we going to do? We're going to show DBs. We got admin and local. Let's start writing some data, guys. What do you guys want to write? Awesome, good idea. Let's store.
Burritos.
Yes. How do you spell burritos? 2 R's or 1? Use burrito. Now we're on the DB burrito. But wait, you ask, where's the DB? You don't have to worry about that. It exists because when you start writing to it, it creates it if it doesn't. You don't have to create a database. So now, let's look at what tables we have, except they're collections because it's an awesome database. Oh yeah, it's just empty. We don't have any. So let's start writing to one. Let's say, okay, beef, yeah, beef. Dot, what is it? Is it? Mongo. I believe it's just insert. I think. Double check me while I'm writing this. All right. So what do we want in our beef burrito?
Queso.
All right. So let's call this toppings, right? Let's make that an array of strings. Why not? We have queso. What else? What do we want? We have cheese. Well, queso is cheese, guys. cheese and maybe some cheddar.
Jalapenos.
Yeah, okay, well, I thought that was-
No, that's a bean.
All right, so into our beef burrito, let's insert some toppings.
I can't see the.
It should be, no, it's, double check me, make sure I'm not insane. Yeah. MongoDB CRUD operations. Remember CRUD, guys?
Yeah.
Create, read, update, delete. That's literally what Mongo does. DB dot. Gosh. All right, so like I said, it's JavaScript. You have a DB object. It is your database. Your next thing is going to be your collection, and then do whatever.
How does it link it to burrito?
Because I said use burrito.
Oh, you said use burrito, okay. never
Right?
mind.
So now we're into burrito. So if I again go show DBs, now we've got a burrito DB. Awesome. Show collections. We have beef. We got beef burritos, guys. How awesome is that? So we just put that in there. So let's make another beef burrito. What do we want in this one? No, don't even say. You guys are not gonna help me.
Sour cream.
Deers.
Right.
What are you not saying? Eggs.
Flavor.
Jelly beans. Booyah.
Who's that really? Oh, guys, it's not going well. Inserting. So we've inserted these things. So let's say GB beef. Fine. Let's find some burritos, guys. Whoa, we have those burritos. So that's the thing with Mongo. Like you said, object ID. Yeah, what's that? So yeah, MongoDB adds this thing called an object ID, which is a way to uniquely identify every single document that you insert. Every single burrito. And the object ID is really neat because actually inside of this, it stores a lot of data. It stores the machine it was created on, something else, and the time it was created at inside of just this little string here. So, let's try to find, let's find one with some toppings. We want cheese, not queso. Why would we want queso? Whoa! It returned. Yeah, there's cheese in there, guys. Right, so we do that. That's kind of ugly. Let's make it pretty. Whoa, JSON, what's that? So now that we made this pretty, you can actually read it. So we looked for toppings. We looked for cheese. It knew that, hey, there's an array here. We should probably look inside of the array. Right? So instead of having to write some ugly table, do a join, select where something equals cheese, let's not. Let's just keep all that information with the thing that information is about. Right? You don't want to, like, have... I mean, what good is a burrito if you've got your burrito with your beef, and then you've got your cheese, your queso, your nothing, you get nothing over here. And then to eat it, you have to go like this. Why would you do that? When you can just keep it all right there, wrapped up in a burrito. Good metaphor, guys. You guys are awesome. So that is just a basic look at MongoDB. Mike has more because
We add awesome to this beef burrito, like an awesomeness level, but only add one.
Why would we want the awesome burrito to have, or the cheese burrito to have awesome in it? I think nothing is way more awesome than cheese. All right, sure. The queso burrito. 'Cause I don't like. I don't like. No. I'm gonna like murder this joke. Like it's so dead. The horse doesn't exist anymore. So let's say we want to add some awesome to it. Now, typically, before you go about like changing something, you want to make sure you know what you're doing. You want to make sure that it actually returns where you want to change something. So always write your inserts, or your updates rather, as a find first. So now we can do update. So now we create another thing, and we're going to write set. We're writing set because if we don't write set, It's gonna take the whole thing and then just replace it with whatever we say instead of just setting things. Or you know what? Why don't we just push it? It's an array, let's push onto it. So Mongo has these funky things, right? That start with $, that let us do all sorts of stuff to like arrays or fields or things. So yeah, it is just push. So we're gonna push into toppings, and we're gonna put some awesome in there. So it matched one, it didn't upsert, but it modified one. So let's go find our queso one again. And now there's some awesome in there. Okay. Now you're happy, Mike. You're happy. All right, so instead of trying to do some crazy stuff with SQL, we can just write it as one nice burrito with some awesome on top.
So your object ID stays the same, right?
Yeah, exactly. Because that's the object. We just added something to it, right? We didn't change the object.
That makes sense.
Does it record the time you updated as well as the time you created?
No. The only reason that there is... Ooh, that's something I could show you. So the only reason there's time recorded is because it's actually encoded into this. This is hexadecimal, and if you decode it, like, there's enough bytes in there that they can store a timestamp.
Or they use a timestamp to generate the ID.
Yeah, it follows a UUID pattern.
Yeah.
But so let's try something else. Let's say set last update to just a new date, because this is just JavaScript, guys. Semicolon, maybe. Didn't like that. We need here. I don't know where my last command went. Huh. Alright, we're creating a new date. Last update, and we're gonna set. Does that work? Alright, we end, everything's good. So now, there we go. Now we modified one. So now we've got this ISO date thing that it stores some really precise time actually. Whereas the object ID just has seconds in it. This has like microseconds because it's a JavaScript date. And that's what JavaScript dates do, because Mongo is just JavaScript, just JSON. So if I wanted to find something, so let's say I wanted to find where the last update, and this is not very realistic, but we can find where last update is less or greater than, let's say, new date minus 3600. What was it? So because this is just JavaScript, this should work. Did something wrong. Did something wrong. Let's try it. What did I do wrong, Mike? No, that's not what's bad. Oh! No. Last update is spelled right. I might have flipped my operators though. So I might have flipped my operators. I may need greater than here.
Anybody built a GUI for it yet?
There are some GUIs for this, but really you're going to be using this inside of a programming language, and that's the great thing about this is that all of JavaScript, because this is all of the different drivers, the PHP driver, the Ruby driver, the JavaScript driver, all behave almost exactly like the command line, just like SQL, but you can just use, like, inside of PHP, you can just pass, you know, a string into your find, and it'll use the string instead of having to build some query with it. So I just need to properly handle my dates. So we could say the beginning of Unix time, January 1st, 1970, because there was no time for that. We can find, it does not work with, there we go, okay. So the beginning of Unix time, that's silly. So the beginning of Unix time was January 1st, 1970. So we created a new date with that, and we looked for everything that had a last update where it was greater than this date. And Mongo knew to look for things that were last updated after that. It also knew to ignore things that didn't have that last update field. So those are just a few ways you can do some awesome things with Mongo. Is there anything else I want to do, Mike? No, I didn't. I did not nail that. That was horrible. But that's a very brief overview. The MongoDB documentation that you can find at docs.mongodb.org do a really awesome job of explaining all the stuff you can do. There are some crazy things you can do, like aggregation. You can basically write some JavaScript. You can pass it arguments. Like you can say match this, group it by this, and then perform this MapReduce function on it if you wanted. You know, don't use Hadoop. Do it right inside your database, and it just works because Mongo is awesome. So there's some really crazy things you can do. Mongo has some awesome support for geospatial queries. So like if you're dealing with locations, you should be using Mongo because you can search, like, you could define a inside polygon, right? You can define any shape you want and find if some arbitrary point is inside of it that you have stored in your database, right? So you could geo-select your users based upon, like, if you found where they were physically located via their IP address, you could geolocate users that are in like a certain voting district and send them an email because you have their email for whatever reason. So there is some crazy powerful stuff you can do that I can't even begin to touch on because, I mean, it's really a little beyond the purview of a lecture like this. But you can do all sorts of stuff. You can do multi-key indexes, and it has even full text search. So you should be using Mongo is pretty much what I'm trying to get at here. Because you don't have to know SQL. It's way easier to write for when you're first developing, and pretty much anything that SQL can do, Mongo can. The only thing it can't is do joins, because there's no reason to do joins because you just store everything with what you want back. So yeah, thanks.
I believe there is a MongoDB user group that needs your.
Yes, actually, my company kind of hosts that. So we run the MongoDB meetup group here in St. Louis. Our last meetup had a guy who flew down from I don't know where, but he worked for, they're called the MongoDB company, these people who develop MongoDB, and he gave an awesome talk on getting performance out of MongoDB and some coming changes and stuff that we run right here in St. Louis. And I have MongoDB stickers, if anybody wants them.
Yours.
Yes, please. Put it over to the Apple though, so everyone can see that. The meetups happen at Lab 1500, which is just at 15th and Washington. So, what?
When are they?
The next one isn't scheduled yet because we need presenters. So, if you happen to like Mongo and know a lot about it, anyone, please talk to us. We need presenters. So that's about all I have for you. If you have questions that are relevant to the entire class, you can ask them now. If not, specific questions, bring them up here.
And it's all open source, right?
Yes, it is completely open source.
Yes.
You can use all the tools.
Yep. Yep. Yeah.
For people from Memorial, where are we supposed to go to do our group studies?
Yeah, there's an awesome space up on the third floor.
It's relational in the sense that you have, right, MySQL wants to store more information or less information than you had previously. So you can write scripts that go through and look in each document and set some default value, or you can just, when you write your code, write in something that handles null values as just not having that information and make your program react as such. And then just for every new thing, write in that data that matters.
You can basically just like simulate like a table or something.
Yeah.
So if you're going to do a table for, say, an OCR, you could actually have information on the document and then store the document inside Mongo.
As far as like storing a file, yeah, there is support for that, but it is far slower than if you just stored it as a file separately somewhere. In that case, I would probably say like store the location of the file or the file name inside of Mongo, and then use the file system to read and write that file.
In case of relational database, you said like we can correlate the data using the query, right? But in case of this, we have to enter the data. So in that case, what if the database is going to get larger? I mean, it works well for small data like 10 or 20, but what if database is going to get larger?
Definitely. So that is something that is fundamentally different and understood to be different about Mongo and document databases is that you will duplicate data. You need to store the data as you want it back out when you're reading it. Whereas with SQL, you store it in a deduplicated manner where you have to do complex queries to find exactly what you're looking for. So yes, you will store the same data multiple times. And Mongo is built in such a way that there's both sharding and clustering built into it, so you can scale potentially more easily than you would if you weren't, like with a normal SQL database, such that that isn't so much a concern as far as size and the machine resources. You would just have to put more resources towards it. And in the end, it will be more performant because you're just literally reading it from one place instead of having to figure out where everything is.
Yeah. And about duplication, how many people have heard database normalization? First form, second form, voice code? Yeah. That's relation. What?
You want third normal.
Yeah, third normal.
Yeah.
Exactly. So those are just degrees of how dry your relational database is. Relational databases seek to be as dry as possible so you don't have any duplicated data whatsoever. And MongoDB doesn't care. It's like,
Dude, throw data at me. Do it.
Data. Come on, just store some data.
Let's spit it
back out.
Yeah.
Yeah, right.
Is there a good tutorial you recommend?
So actually, I'm glad you asked because MongoDB, they actually have, I think it's under Try It Out. So they have a MongoDB shell in the browser. So it gives you some basic information, and then I don't know where the link to it is, but MongoDB tutorial. So they actually have.
I think in the developer Mozilla has a JavaScript guide you can use also for Mongo.
Okay, yeah, I was looking because I know one of them. MongoDB themselves actually have a little thing that if you, there we go, MongoDB University, that's what it's called. So this is not what I'm looking for. MongoDB themselves publish it's basically a tutorial walkthrough series where at the end of it, if you complete everything, you get some pretty little online certificate that doesn't matter at all, but it's nice to have. I can't find it right now,
Yeah,
but
it's docs.mongodb.org and then /manual/tutorial, and then it's the install for each operating system, whether it's a Mac, Linux, or Windows.
There you go.
yeah, this isn't what I was thinking though. This is a great tutorial, but it isn't. Yeah, it isn't what I was thinking of. I will find what I'm thinking of because it has you do it like this right in your browser, but it has you do all sorts of complex stuff.
Will you put that on Reddit?
Sure, I will put that on Reddit. On Reddit, I am terrible at CS50, so.
So the certification tutorial is one that is published by Mongo.
Yeah, I mean, the certification isn't worth anything, but it's basically some very good first steps, right? All right, so, anything else?
You guys have more questions, we're hanging out in the lobby.
Yeah, we'll be in the lobby. We should probably be getting out of here.
All right.